Part of this presentation would be introducing 3D modeling using four basic tools. We have the extrude, we have the loft, we have the revolve, and we have the sweep. So we're going to be using those four tools one after the other to introduce to us what we mean by 3D modeling, just in case we're not interested in using the already predefined solid geometries. Firstly, let's say we choose the rectangle and we draw a basic rectangle. I selected my first point. Let's assume I want to select the next point at the same 700 and 100. Okay, X and Y. So I have that as my rectangle from the top view. And if I look at that drawing southwest isometric, I just have a basic 2D representation of a rectangle. Now I want to introduce the Z direction, or I want to go from a 2D to 3D geometry. That's where the extrude command or these four tools come into play. So basically, if we want to switch or go directly from a 2D geometry to a 3D geometry, then you want to play around these four tools. Okay. So let's start with the extrude tool. Then if you look at command line, it's going to ask me to select the object I want to extrude. I select this rectangle. I click enter. It's going to ask me for the extrusion height, right? So we can see what's happening. It's already introducing a Z coordinates to the 2D shape. And I specify a height of 100, enter, and I have this geometry. Okay, so I have a geometry that was gotten through the use of the basic 2D draw command and an advanced 3D command, which is extrude, right? So I have it in this form. And I can do the same thing that I've always been doing. I can put it in different viewports. I can look up different views and so on and so forth, right? So let's delete this. So if you understand that, the same thing goes for a circle. We have a circle of this form. We can extrude the circle. You can extrude the circle, specify a height, and we get a cylinder. Okay, so we can basically play around with 2D objects, right? We draw it, we draw a 2D object and we extrude it to change it from 2D to 3D. Okay, so if that's clear, let's go straight to the next tool, which is the loft command. All right, the loft tool. So for the loft tool, I would want to explain it in this way. Let's assume I have a certain circle of this form over here, and I would want to do something like this. Center of the circle, let's say I just want to draw center line through that circle, and I want to have this guy and this guy. Okay, now I want to draw another circle just at the top, right? It's at the top, and basically we can't draw on the Z plane, right? So because I can't draw in the direction of the Z plane, I need to use a UCS to change that, to change the Z direction. So instead of coming here to change new UCS, I can simply come to this, this tool and click Z axis. So I want a new Z axis. I want my Z axis to be in this direction. So if my Z axis is in that direction, it means I can now draw a line up here. Okay. Again, I want a different circle just at this point. I want a circle at this tip, right? Probably a larger circle. And again, because I can't draw on the Z axis, I would want to change back to the world coordinate system so that I can come here and pick and draw my circle and have a very large circle, which is okay. So I want to introduce my loft command. So for the loft command, I just click the loft tool, and the command line is asking me to select cross sections in lofting order. So I want to loft this guy straight to this geometry. And if you do that, you can click enter and click enter again. And you see that you've arrived at the geometry in this form. Okay. So we can loft basic geometries together. You can loft a smaller rectangle with a larger rectangle, smaller triangle with a larger triangle, and so on and so forth. Right. So that's basically how the loft command works. I want to go to the revolve command. Okay, so to go to the revolve command, let's simply delete all this and let's again start from the top view. So starting from the top view and switching over to the WCS. Okay, so the WCS top view, I want to pick a polyline. Okay, polyline is a line that is continuous, right? So I pick a polyline, I go in this direction, let's just say I'm trying to introduce to us, I'm trying to introduce what the basically the revolve tool is all about. Okay, so I have a geometry in this form. I'm sure you can't imagine what this geometry would be if I revolve it. Revolving means I just have a cross section. I want to revolve it through 360. So let's revolve this geometry from 2D to a 360 revolution, and let's see the type of geometry we'll be obtaining. So let's again switch to southwest isometric, or let's switch to northeast isometric. Okay. Now let's pick the revolve tool and click the command line is asking you to select the object you want to revolve. I select this object, enter. It's asking me to specify the paths of revolution. So I want to revolve it along this path, right? Let's say I want to revolve it along this path. And it's going to ask me the angle of revolution. The default angle you see here is 360. So you can just click enter. So revolving that geometry I just drew in 360, and we've introduced, an object in this form, right? So with the help of AutoCAD, I can give you your glass cup, probably for your wine. Okay, use that to enjoy your wine in your home. Okay, so that's good. So now we've, we can see what the revolve tool can do. Basically, it's revolving a 2D shape in 3D by any angle. Okay, that's good. We can also use that same revolve to generate some lovely, very, very lovely geometries. So let's go to the fourth tool, which is the sweep command. Now for the sweep command, I would want to, again, let's say we start from the top view, and let's switch this to the WCS. So for me, I want to have this certain circle. Okay. And let's say I want to switch at this point to the southwest isometric. Okay, I have that circle. I want to sweep that circle through a certain path. Okay, let's just say we come here and we come to select what we call an helix. So for this helix, the first command telling me to specify the center point of base, right? So I select that as center point of base. It's asking me for the radius of the base. Let's just say I take an arbitrary radius. That's the radius. It's going to ask me for the diameter of the top section. Let's say that same radius is the diameter. And now it's going to ask me for the height. So to select the height, let's just say I take an arbitrary height and I go in this form, right? So I have an helix. Now my aim of getting this helix is I want to sweep this circle through the path of this helix. Now, how do I do that? I simply have those two geometries. Then I come over here and select a sweep tool. And the command line is asking me select object to sweep. I select this circle, enter. It's asking me to select the sweep path, and I select this path. And if you do that automatically, basically we see that it has simply swept a circle through a certain path, and you have the geometry of this form, right? This sweep command is actually a powerful tool. We'll be using that as along the line. Basically, typically when we're interested in drawing bolts, threaded bolts, sweep commands becomes, the sweep tool becomes our best friend. Okay, so basically now I've introduced us to the four major tools for editing 3D models, right? This 3D solid modeling, the four basic tools. We have the extrude, we have the loft, we have revolve, and we have the sweep. Okay, and if at any point in time you forget what they are used, the application, you can always come to the tool and just, keep your mouse there for a while, and it's going to explain to you basically how this tool works. Okay, so if that's clear, we are ready for the third part of this tutorial, or rather of this presentation. Okay, so if we want to start at the third section, basically, let's say I start again from the top, and again I switch to my WCS. And on the third section, basically would want us to get, some drawings. From the drawings you see, for the presentation, PowerPoint presentation, we see that we have to draw a certain geometry in 3 dimensions. Now to start, I would